in. Yeah. 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 No, absolutely.
Is that
Or the final.
yeah.
Well, and that's a little bit great at that, which is why I want to go to it's not, you know, because everyone goes, oh, what do you look at the middle? But I think no, it's not specific bits, it's just work out where I thought I was as opposed to gone to
Yeah.
why there's different stuff. But no, but what's the problem? You got to have one. You can have 2 weeks. Suppose someone else for it.
I will. Yeah.
I don't want to pick with.
So how's your stuff going?
Not too bad. A bit behind on a few things, but
Yeah,
yeah.
I think your exam will be on 18th. Did you check?
Yeah. Which
18th.
exam? Data or?
Yeah, data fundamentals of 18th, I
I
think.
thought the corporate was the 18th, and that was the day after.
I'm not sure. I don't remember the exact dates. I know it's like the Tuesday, Wednesday, the second week.
Well, I don't remember it on Wednesday in the second week.
Always just let's have a look.
Alright,
Yeah, they can't get the court expression.
so
Status.
oh my gosh. It's full, huh? Okay, I think there's no space for the USB.
No, it's
All full.
Yeah, on the table. That this in that very.
That one? Ah, this one.
Alright.
Nathan, you should do PhD, no master.
I'm not going to
Tell
tell
it's a
you.
waste as a student, why it's electric.
So, guys, today we're gonna have a quick review about what you have done last week. Plus, that's some story about your business report. Would you like me to?
Yeah.
I'm just want to tell you one thing is important, guys. In general, your answer is good, but on how to present, Nathan is not happy with this stuff. But guys, you're a master student. When you present the work, it has to be more professional in terms of the organizing, using the lines, heading, stuff. You know what I mean?
Mm-hmm.
So every question has to be in new page, title, and how to present the results and calculation. Be more organized. Mine is done. Our exam is done. Gone. But next for future, be more organized. If you don't know, there is something, call it Google, YouTube, stuff, right? So if I don't know, go Google and find the solution, so find the structure. Anyway, that's just a recommendation for you. In total, the business report is good. But somehow, most of you guys, in general, is top. In general, top. From my perspective, compared with the previous group semesters, no, it's good. Very good. But you need, anyway, I think that's the level of all students. Some students got full marks, some, I think one got full mark. One. No one got full. Also, but near to be full. So, but it's good. In general, very good. Not just good, trust me. Let me just check the ad hoc. working. Yes, working, huh? So that's about business report. So I think the result will be uploaded on the system very soon. It's almost done, but still there is some stuff. Some students still in the mid of the journey because they deferred and stuff. Working. Nicholas. Okay, I think we can organize it like that. So, just quick review about what we have done last week, guys. So today is the last model, you know that?
Mm-hmm.
But still, we have something to do next week, like the tutorial questions for model 11. Right, so be careful, you have to come. So, last week we've done the multiple regressions, guys. The conditions and requirements is same with the simple linear regression, except some stuff like the adjustment, because we have more than one independent variable. Do you remember it? Because we have more than one variable, we have to use the adjustment. Because when we add more variable, maybe the R-square will change in terms of the positive or negative, because you control more about the environment of your data, right? We control 4 more independent variables. So we have to check the distribution of the stuff. Data has to be independent, error terms, and so on. So standard error has to be less than 20%. If it's more than 20%, that means it's large. What we have to do, we have to take the natural logarithm of y. We have to play with the y, with dependent variable. Like natural logarithm of y, like square power of y, or square root of y, or y dependent 1 divided by some calculations. Or test, but normally we use the natural logarithm, which is the best used in the literature, because we have to follow with the literature. Guys, with the test of the utility, when we say testing utility, that means you have to put the hypothesis tensor and check. With the F statistics and F significant. Do you remember F significant? I said it's equal to? I'll show. It's statistician. So p-value. P-value, we use it when we have H alternative hypothesis not equal to 0, different from the 0. When different from 0, not equal to 0, that means we're going to use P. Otherwise, if it's greater than or less than, we're going to use critical, right? Statistics. Critical. Yeah, with the simple linear regression, if you remember. It was T, right? Use T. But when it's different, directly. Because with multiple linear regression, we have different, right? Because we don't know, we have to test. We have more than one independent variable. So it will be different. Maybe some independent variable will be positively associated with the y. Maybe negatively. So here, the direction will be, depends on the regression results. Excel output. Okay? So normal I-square, as you know, greater than or less than, between 0 and 1 of the percentage. The bigger the better, I-square. Because as much as you're going to big I-square, that means the observation, non-observed frequencies by or values by they will be less. When it's less, that means the models fit the data. That is the general. Other things like y, the predicting model or observed model will be y equal to beta 1 plus beta 2 x1, beta 0, sorry, with the intercept, plus beta 1 x1, right? That's the model, right? So then use predictions. So that steps is same with the linearity. In term, just accept some stuff, right? So do you have the question, guys? I print some. So it depends on your lecturer. He will bring it here. I'll print it, right?
Thank
He will
you.
bring it to him. No worries.
So which of the statistics is saying how much change variable?
Y will be explained by,
Yes,
that's R squared.
that is the R squared.
Yeah. So here we adjusted. That's why we're going to have one example in here. We're going to explain. So have a look to the first one, guys. In the exam, guys. Did I give you? Yes. In the exam, the nature of the question number 6 will be same with the one now, but it will be much bigger, a little bit bigger. Not much, that much bigger, but a little bit.
Okay.
So I will ask you such a question, guys. I'll provide you with the Excel output. I'll provide you with the Excel and ask you some question to answer, like what's the variation in A, Y can explain by X, for example. So in here, just have a look to the question and see if you can identify some sort of stuff of points, guys. Mine. It's very easy, by the way, the regression. By the way, regression is a very important model in your journey. So, to get the actual value of the lot, guys, in here, you have to have some additional control variables, right? So, the control for lot size, which is, so somehow it's, if the size, the size of the land is big, that means the price will increase, right? Because you want to predict the actual value of the lot, right? So the first question here, see, what is the standard error, guys? What I want you to do, guys, in the exam, I want you to see the values, for example, price in $1,000, right? Right, guys? That means when we have, for example, here we ask about the standard error. So how to address that? We have standard error provided in the Excel output.
Yeah.
But when I want you to interpret, because we use the small figure of the numbers, that's why it become 40.24. So but what I want you to do, guys, to times that by 1,000 exactly. Otherwise, you're going to get half. I'm not too strict. I will give half, not 0. Okay? Half of the mark. Or half mark. So, see, guys? Now, first question they said, what is the standard error of estimate? So we got R squared. The estimation or the estimated value of the house lot can vary from the actual price by, right? That's the standard error. By 40,000 to 40, right?
So why do you multiply by 1,000 for part A?
Go to the price. Price, go, read the question.
Column 1. Prices
So
of
one
thousands
says
of
column
dollars.
1.
Thank you.
So check this important points. Guys.
Mhm.
Do you remember last week and the week before I said to you?
Yeah.
Because we use the small figures.
Yeah.
Now I'm doing some projects, so I use the small figures, but when I do the conclusion, I have to use the original figures to interpret. I give the idea for the investors that this is the variation and stuff like, right? For example. So how about the second one? Coefficient of determination. Coefficient of determination. So normally you can put the R square and put the adjusted R square down. Why? Because it differ from because we have multiple, right guys? It differ from R square, the adjusted one, because it includes an adjustment for. If we have simple linear regression, we just have one independent variable, right? But here, when we control for more variable, maybe R square will be less, or maybe it will be greater than. It depends. So see, the R square, not adjusted one, is 24, right? When we control for more variable like lot size, like number of trees, like distance from the city center, so the R square becomes less. That means, what does that mean? That means we have to check the price. Maybe the price figure is not correct. Maybe we have to take, which one? Maybe we have to take, for example, the natural logarithm of the price. Maybe it depends, because that's going to become adjusted, become less, right? It has to increase, not decrease. That means there's some problem with the data.
Right.
So that's why we suggest, normally, we run a couple of regressions. Trust me, when I was a PhD student, sometimes I do 2,000 regressions per day. 2,000 regressions. How? Play with the data, not just y. In your case, just play with the y. Take natural logarithm, square root, right? Power 2, depends on the, but you're not going to use it, I think. You can use it in model 11 today. I will show you how to do it. Very easy. But in this case, because when we R square decrease, that means we have to find the reason why. But it's not important.
So we should use, so the answer should be the 24.
For the multiple, because in final exam, most probably will be a multiple. Because the first requirement of question 6, I'll ask you to predict or estimate the model. Do you remember last week? I said to you guys, put y, put the numbers, stuff, the name of the variable, and then equal to beta 1, put the value of beta 1 plus x1 plus x2, x beta 1 times the number of the variable, like x1 equal to this value, some sort of thing. So that's why I said to you guys, next week it will be a revision. What you have to do, I think the mock exam, I check it's ready for you. Did you check it, guys?
Not yet.
The mock exam is ready. Next week, you bring it with you. So, okay, I will tell you at the end of today.
Yeah.
No problem. Not go to mock. Still, within this stuff. All right, guys? So the coefficient of determination, it's R square equal to 24%, right? But the coefficient of the adjustment degree will be more suitable. That's C, right? Because we have more than one independent variables.
Mm-hmm.
So that's why when you run using the modern statistical software, guys, the software will give you a broad idea, everything. And you can read, you just look to the output and check the table. You can read R square, standard error, the t, p-value, the association, significant or not, everything. All right? Test the overall utility, guys. I told you just now. When you say test the overall utility, what you have to do? So imagine you have the exam and you find this one. Test the overall utility. That means you have to test the hypothesis. What you have to do? Put the hypothesis. Test the utility hypothesis.
They're saying, because
Determination of determination.
Yeah.
Not the adjust, because here we ask about the R square and the adjusted R square. But maybe in the final exam will be just because we have multiple regression. If it's multiple, adjusted.
And so that's telling us that 76 or
Yeah.
80% of variation is not explained
By the, yes, by the three variables. That means there is some errors. Yeah. That means there is some errors in the calculation of y. We have to test, but it's not your level. Just stop here. That's it. A question of testing utility means how many variables, independent variables we have, guys?
3.
3. Loss size, number of trees, distance from the city center, right? That means beta 1 or beta I equal to beta 1, beta 2, beta 3 equal to 0. At least one of beta I, which is that one 3. So in exam, I want you to say that. If you want to say beta 1, beta 2, beta 3, before that, please tell me what does mean by beta 1. Or if you want to say beta I, you have to say before beta I, you say beta 1, beta 2, beta 3, beta, right? How many betas you have? How many independent variables? But not just jump to say beta I equal to 0, beta I not equal to 0. No, I want you to say beta 1 equal. That means you understand that all these betas, you have 3 variables. That's what I want. So follow this structure, okay? So if you go back, test the utility. What's the question say, guys?
Test the overall utility of the model. What does the p-value of the test statistic tell you?
What does mean by that? That means what you have to do? We have F test and significant F. F test equal to?
5.97.
Equal to, because I can't see it. Okay? 5.97, right? How about p-value?
Which one do we take?
0.00, not just 0.3, Nathan. If you say if you say 0. Why? Because here we're gonna identify that beta value less than alpha. You agree with me, guys? Because you have 3. If we said 0.03, that means greater than 0.01, right?
So the p-value, can you just confirm again?
Yeah, p-value less than alpha, reject null hypothesis.
Yeah, but the p-value that we look for is significant.
Significant. With when? When the alternative hypothesis? Yes. P-value from ANOVA table. From ANOVA table, by the way.
Yeah, yeah.
Please highlight ANOVA. From ANOVA table. So I use my body language a lot.
It's all good.
So don't be scared. Because when we came to Australia first, and we were doing English course, by the way, when I came, I was good in English. But still, we are non-English speakers. We speak to English. Sometimes we mix it when we speak with our friends from same country. Trust me. So you have to use your body language, and we have to use body language. So we use body language when we talk about kids, when we talk about with kids, wife, stuff. Yeah, don't scare about that. Okay. Okay. Not equal to 0, and ANOVA table use F statistic, F stat, and significant F for p-value.
So what's the F stat telling us? The 5.97?
Yeah. Now, what's the logic behind p-value? Do you remember it? The rule? P-value. If p-value
Is less
than alpha,
Yeah.
reject null
How do
hypothesis.
you know our alpha? Does it say?
Yeah, 0.03.
Oh,
Yes.
there.
Ah, that's wrong. Got it?
Well, what does the F statistic show us? You're at 5.97. What does that signify?
That's F statistic.
What's that going to show us?
This is we compare it to check whether we accept or reject null hypothesis. This is the base. The significant association is not from ANOVA. here, when F tell us in here, if we reject null hypothesis, that means there is an association. But the association will be identified by the t-stat in here.
So do we need the F statistic at all?
Just to decide whether we reject or no, accept null hypothesis. That's just in here. Yes.
Why is it that you've decided that the significance level or the alpha is 1%?
I don't get it. What?
So you're testing the p-value against an alpha of 1%. Is that correct?
Yeah, just by the question, or just we give an example. This is just a default value. Sometimes we use it.
Oh, okay.
Yeah, but in here.
Why not 5? Why not 10?
Oh, right. But in here, it's less than alpha on all levels. So, but we said it's like, I think it's, check the question. Test, no, there is, I think.
Test the overall, what does the p-value of the test statistic tell you? It doesn't say anything.
Ah, yeah, but the question, anyway, it's just a default.
Okay.
Default. But compare the F, here, this step will tell us to accept or reject null hypothesis. Now, we're going to reject null hypothesis. What does it mean by that? That means there is an association. How to check this association? Next step. Let's go to the next step, we'll see. So, directly, guys, when we are doing some tests, guys, do you have questions? So the first 18.7 or 7, you got it?
Reject null hypothesis.
See, when we run the result in here, this table, guys, will give you a broad idea about you. So first, we want to test the hypothesis. Okay, how to test that? Because we said, it's equal to 0. And the alternative will say not equal to 0. So now we confirm that there is association, but still we don't know with which independent variable there is association between x and y.
So we can say at least one of the betas is not
It's not 0. Good on you.
Yes.
So how to, next steps, we're going to use t-stat. So here's the significant. Right? 2 point, that means significant at 1%. If you go back to the table, that, if you remember it.
that table.
So this is steps forward. Let's see how we go with it. So what's the test the overall utility? Does p-value,
So for D,
to determine,
the model does have utility. Would that be the final?
yeah, I mean, that's the utility. So lot size, see, 0.699,
Yeah, I see. This is E.
right? The coefficient in here, the beta 1 in here, guys. Beta 1. It's too big beta. Right, guys? So we have to interpret it, the value of beta 1, beta 2, beta 3, right? And say, because some is negative, some is positive, right? So we'll give us the direction between x and y of the association, right, guys? So here is increase, here is increase, but here is decrease. Why decrease, guys? Huh? Because of negative sign. So
Each 100 square meters, the average price is like $6,000.
okay. So that's so test 10 determine whether the independent variables are linearly related. So see, you can see that lot size linearly, but it's not that much significant, I think. Let's see the significant. It's linearly related to the price of the lots, right? I think we can use t-stat in here and p-value. Let's see. So F is test that determine whether each of the variables is linearly. Guys, when we say linearly, that means, see again, guys, utility and linearity has to put the hypothesis. But here we have to prepare a box to check the differences between, to check the linearity of the association between x and y, right? Because guys, any value of x will have some association with y, but this association maybe will be positive or negative. So the first one, lot size. Please look at this one and think about it. Are you guys with me? Test the linearity. Okay? See. The linearity in here, guys, that means we have to check the t. Do you remember I said to you? T-stat and p-value. See, T-stat is not significant. When it will be significant? When it will be more than?
2 points.
No.
Wrong.
The significance between x and y start from 1 point greater than 1.65 till 1.99. This is significant at 10%. From 99 to 57, right? It will be significant at 5%. Greater than that, 1%. Very strong association. See, now in here, the t is
1.25.
that means it's weak significant, right? But the p-value is, see, how to compare in here, based on the question, they use p-value in here. But still the t-stat is better.
So in
Normally-
exam, we would use the back of the
No, I want to use this one,
p-value?
this shape.
Okay.
You put the variable name,
Yeah.
lot size, and the t-stat, because I want you to see whether you understand the stuff. Because here, I want you to check the
But here we're still using P and alpha.
alpha. Yeah.
We're not
Well,
actually
because but you have to put t, because t will give you if there is a positive or negative association.
okay, yeah.
I mean, significant or statistically significant,
Yeah.
or statistically not significant.
Sure.
Okay? So here, we put p-value from the table, guys. 21 or 0.21, right? 5, 6. So use just 3 digits, guys, please. Don't use too many decimals, huh? Like what some of you guys done in the business report.
Don't look at me with my 6 digits.
Okay? So for the first one, P greater than alpha at all the alpha significant levels.
Yeah.
That means do not reject null hypothesis. See, do not reject null. If you think about it more, guys, see, do not reject null hypothesis. That means all same. Why they said in here like this? Because if you, okay, the rule, compare P and alpha. But if you, from myself, this is for myself, not the rule, myself. If T-stat is not significant, reject at 3%, right? Reject. But don't reject at 10% because it's near to be significant, right? Anyway, from my perspective, I said reject at all, but in your case, no. Do not reject, yeah. Do not reject at 10% because p-value greater than 1 and 5 and 10. But you can see that 1.25 is near to be close to be significant. So don't, but sometimes just say don't reject null hypothesis at 10. This is in your case, in your material, your unit requirement. For the second one, guys, check it. What is the t-stat and what is the p-value and what is the significant level? Check it for the next one.
Okay. T-stat 2.
Put it, please. This is a good practice for the final exam because that one will allocate the maybe 40% of your total mark on question 6. This one.
Right.
So because there's also additional explanations. Trees. Why we reject null hypothesis here, guys? Because there is an association between x and y.
Yeah.
Right? Okay? CT value, T is that? It's very strong. Greater than 2.57. That means significant at 1%. Very strong association. That means trees, if there is a lot of trees in the house, the price will increase. So it depends on the data that we have. Right? You have a question? So use p-value. Don't worry
I
about
was
it.
going to say, yeah, what's the p-value showing? I don't.
So because if p-value greater than alpha, okay, that means there is no association. It's not significant at any significant level. Okay?
Whereas for lot size, because p-value was greater than alpha at all those, we don't reject.
Yes, we don't reject. That because there is no association. That means null hypothesis is correct.
So they're just supporting each other.
Here, trees is significant. We reject null hypothesis because there is association different than 0. Huh?
So you could use t-stat or the p-value?
It's, you know, as a statistician, when I run a regression using software, I directly look to the system. But in your case, no. I want you to put this table exactly in the exam. That's why I said to you, mock exam, this is our material at the end of today's class. You got it? You got it, guys?
This last one is interesting.
How about last one?
Rejected 10 minutes ago.
Don't reject at 10, at 5 and 1, sorry. Because it's significant at 10. Right, guys? You got it now?
Yeah.
Clear now.
Yeah.
Right, guys? You get it clear? You just keep silent. What's wrong with you? You need to share. Be more activated, huh?
Don't reject.
Stan, how's it going?
P is greater.
You got it? Fine? Guys, okay. For those who came a bit late, please review the question and try to analyze it. If you don't catch the point, come and see me. By the way, I already released the pre and post exam consultations. So you can find it on the final exam, but I will send an email today, because a lot of consultation was today. Most students cannot send. I don't have time, so I will send an email to remind you that the consultation hours for pre and post exam will be start from here, end from here, and you can find it on the final exam folder. Because you have business test, business report, and final exam, right?
Mm-hmm.
You can find it under that folder. It's already not hidden for you guys. It's unhidden. So, okay? So, sorry. I'll be fined by the boss. Okay. Only trees and distance variables are linear because there is an association. But the distance from the city is negatively associated. But don't say in the final conclusion in here. This one is important, guys. This one also important. Say only trees and distance variables are linearly related to the price of the
So
lot.
10% then is the minimum significance.
Yes, it's significant, but it's very weak. Sometimes if it's at 5, means 2 star.
Right.
At 1, 3 star.
Right.
At 10, 1 star. That's
Right.
some of them don't accept 10. They said we need at least 5% significant, statistically significant association between X and Y. Especially if you use less independent variables, the association has to be high, right? If you use more independent variables, that means you reduce the error and you increase the R square, or determination of R square, yeah.
What does that mean for using lot size in this?
No, these variables,
Yeah.
these variables will identify the optimal price of the lots.
Yeah.
Maybe we can use another independent variables,
Right.
like if it's a corner or if it's within the complex. This is dummy variable, 0 or 1, right? maybe we can use another variables like if it's in an urban area or rural, right? So that's why now I have one study for Australian government. I use 180 local government data. So to test this sustainability, because they spend a lot of money to check the cost efficiency as a Y. So, but there is an independent variables like whether is the location of this local government work within rural or within urban, right? So there is some differences, right? Or, for example, whether it's on the beach or it's not a beach view, right? So this will identify the price of the lots, right?
Yeah, but the size. So I'm talking about the size.
Yeah, the size.
So what can we say now about lot size as an independent
It's
variable?
not associated, not affect the.
We shouldn't use it as an independent variable.
No, we should use it.
Oh, okay.
We should use it, but the size to somehow within the data we have, because when you collect data, we collect data, for example, from the lots or the size of the lands offered by the real estates in Perth. So it will be different from the size and stuff offered from the real estate agents in Sydney or New South Wales. So there are some differences. That's why we have to control for the maybe in lot size in South Perth, you can buy 5,000 square meters,
Right.
and 6,000, there is no much differences.
So there's still a relationship
Right?
to the price. But it's
Yeah,
not-
but
it's
not
a linear-
significantly linearly affect directly. But the trees and distance to the city is important. This is the nature of the data. But from my perspective, as an accountant and as a, we work a lot with this sort of regression stuff. There is some problem with the variables we used. Maybe we have to, this is additional for you guys, because based on your question, I have to go out of our unit requirements. Maybe because of the lot size to somehow, or the price, we just take the 33.5, for example, or 34.2, for example, for the price, Y variable, okay? What we have to do in here, if there is, because it's illogical to say the lot size is not associated to the price. It's not logical, right? It has to be associated. At least significant at 10%, let's say, right? That means there is a problem with the data we have. What we have to do? We have to take, for example, the natural logarithm.
Oh, yeah.
Why? Because maybe there is some lots is too big, like 99.5, for example. The price is very high. And all of lands within, so there is a technical issues. We need to take natural logarithm, square root. There's a lot of techniques. Later when you do research, guys, if you are interested to do some research, or you got a job and you're going to do some association, put this suggestion in front of you, or Google it. You can have a heaps of suggestions. Take the natural logarithm, square root, divided by 2, power 2, a lot of, right? So sometimes we add one to make it consistent. Maybe there is some outliers. So outliers will affect. So what we have to do, we have to onsorize these outliers and make it consistent with the data that we have. So if it's here, we have to make it within this. So this is some codes in the software on Starter or SAS or the SPSS or something. How's it going?
Good.
Not too bad, huh? So don't depend on the first regression outcomes in the real life. Don't depend on it. Do extra, because if you told your real estate manager that the lot size in South Perth not associated with the price.
Yeah.
What? What do you say? You are not a good statistician or accountant. just get rid of this office, right? Okay, this is, but you have to work and see what is the, that's why there is something, but it's not in your unit requirement. We've got pre-estimation tests. Pre-test. We test the data before the regression. But this is not, this level.
Too much for now.
No. Too much. All right, guys, have a question? Jump to the next exercise. Oh. On your requirement, just see the Excel output and comment of that based on the questions that you have. Maybe you have 10, 12 questions in the final exam. Man, it's 28 out of 100. So it will be more than 25% from the total grade of the final exam. So it has to be heads of questions. But not maybe one question or two requirement will be out of the normal environment.
Oh, okay. Yeah, I see what you're saying.
Huh?
Yeah.
To check whether there's some students are really interested with the unit and stuff. So how about the next one? Another question, which is exactly similar to what we have done before.
Yeah.
So now they change the setting. We want to predict what could be the monthly sales of plastic boards, right? In the hundreds. That means if we say R square has to be times 2, 100, right? So what do you think? It's easy now, right? And put same explanation from what we have done the first, right? So first one, what is the standard error of estimate? So the estimated monthly sales of plastic board can be vary from the actual sales by 4,000? 13, exactly. This one here, guys. So take the please take just for 2 decimals.
Yeah.
No more 2 decimals, please.
I know, he's looking straight at me.
So because, not you, Nathan. I'm not saying Nathan. Did I say Nathan? Right?
The implication was there, though.
No, the facial expression. Because it's 5 students in the class, so okay, I will look to the wall. Don't use to the right. You want me to say that? This is the last day, guys. This is maybe next. This is last semester for you, right?
For me, yeah.
Final for all of you guys. Final semester, last semester. You still have another unit. Oh, okay. So we'll see.
Your last semester.
So next week when I say, so
Parking out early.
so when I say see you next semester, you'll be in. When I say next semester, next week, I will say see you guys next semester. Because some of them last Tuesday, I say see you guys next semester. They was unhappy. We don't want to see you. All right, guys. So
Doing corporate accounting again, I see.
you're gonna do corporate accounting with the. You're already with us, right? Oh, no, the other one, your friend. Yeah, I will be the UC for corporate accounting instead of Lisa. Yeah. So it's a very interesting unit. We have the Zero software, and instead of Excel, this Zero is your friend with Zero.
Zero's great.
Zero, cloud-based software. Anyway, the first one is for. Pardon?
A lot of people like Zero. It's just really easy.
Yeah, Zero need a lot of practice. Every software, guys, every software in the life, especially the one deals with the, statistics and accounting softwares like Zero, like Excel, like This is software is a common software with our life joining with this accounting and statistics. Especially in accounting. As accountants, we use most of these. Statisticians don't use zero, but we use Stata. It's their software on Excel. It's their statistical software, but we use it as accountant. That's why we mix between. Right? So how about the B? What is the R square?
We can use standard error compare models, not the validity of this model.
Somehow, yeah. The model validity, exactly, determined by the R square. So now it's 40. In common, they said if it's greater than 30, will be, but still you have, I mean, here we still have around 60% of the observation. That means, see, now in here, maybe there are some mistakes with the calculation. Maybe the model is not fit. If you want to double check, you can play with the data and see whether you can increase or decrease or square. If it's decreased, that means there's some problem. If it's increased, that means you're going to get better model, more fit, right?
Yeah, okay. So
that's
this one's less to a lesser extent, but it's still the same problem that our adjusted.
Yeah. See the adjusted one will be 87.
Yeah.
That means the independent variables help to explain the unobserved variances between X and Y.
Okay.
Right? How about the adjusted is, as I said to you, 87, right? Times 100?
Yeah.
So 87%, say like that directly. So, but just the one,
It doesn't differ much, right?
yeah.
But it's still lower, right? But not
Because what happened? What happened? That's why. You remember, guys, when we said to you guys, we use the multiple instead of single linear or simple linear regression. Why? Because when we increase the number of independent variables, the model will be more fit. Right? With the first one, maybe there is some indigeneity. That means there is some causality effect because of the numbers, not because of the logic of the association. Huh? This is a bit advanced. Leave it. Okay? So how about the next? Test the utility. Sorry. So test the utility. You got it? Okay. So you can take for up to you. Ah, we have time. So, almost 1 hour.
Yeah, I know.
We
We
have.
asked too many questions.
Yeah. You test your utility.
Sorry, go.
Test utility. Oh, sorry. Okay, Nathan. So I said Nathan again. Franco. So test the utility and see how about the F and significant F to test the usability of null hypothesis, whether it's rejected or not. So what do you want to see? F statistic equal to 39, right guys? So how about the significant F, which is the p-value? How to measure that? Do you remember, Franco?
Divided by 10.
If it's big number,
Divided
5 point power
10 to the power of
9,
9.
right? So that means very, very small number.
Yeah.
When there is this one E in here, that means it's very small p-value. Okay? That means we reject null hypothesis. That means there is an association. But still, we need to know what is the nature of this association. That's why we check the coefficient of beta 1 and beta 2 and beta 3. Because we don't know the nature if it's positive or negative. Right? In terms of the permits, in terms of the mortgage, vacancy of the apartment or office. So we still need to check the beta 1, beta 2, and beta 3, and beta 4. Please take photo for it. So this is easy just to check whether it's increased or decreased based on the coefficients, beta 1, beta 3. If it's positive, that means increase by the number times 100, right? Again, the next one, mortgage. The coefficient value? It's not sorry, it's not, just put the coefficient, the errors times 100. The beta 4, see, it's, the one is increased, positive, right? The second one, mortgage, Franco, positive. That means increase, positive. Increase in X lead to increase in Y. So how about the vacancy in the office or apartment? Negative association, right? Why? This one sheets.
1,552.
Right, so how about the last one? The last one is positive, right? Increase. Increase in Y lead to increase in X, sorry, lead to increase in Y.
Yeah.
Right? This is just normal.
Yeah.
Okay? Calculations. But check, guys, it's times with 100, right? Times 100, right? The coefficient's value here is times 100, times 100, times 100, times 100. Okay?
Yeah.
How about the next requirement? No time, guys. Hurry. Where's my eraser? Man, 7:30. I wake up around 5. Honestly. Thinking, doing some work, consultations. 4 or 5 students come before who came to the class. Some of them deferred. Still, oh no, we don't want. So how about the linearity, guys? Linearity or the
Yeah.
yeah. So what do you think?
Let's have a look. Permits linearly.
So when we said linearity, that means we have to put the hypothesis like the utility. Linearity, put the hypothesis. H1, H0 equal to beta 1 equal to beta 2 equal to 0. The alternative, HA alternative equal to different than, or beta I, say beta I, but put between 2 brackets 1, 2, 3. Don't forget it, like this, please.
Yeah.
Because I want to know that I equal to 4 independent variables. Okay, guys?
Mm-hmm.
So, the second step, okay?
P-values, T-stats, alpha.
So the first one for permits, so you put, it's reject null hypothesis. Because it's, if you go back to the, it's T, very strong.
Yeah.
Very strong association. Here, we reject null hypothesis. That means there is association between, which is a positive association, right?
Yeah.
Positive association.
Yeah.
Ooh, it's very strong. So how about the next one?
Weak.
So p-value is,
Do not reject at any alpha.
do not reject at any alpha, right? How about the vacancy in an apartment?
Do not reject at any alpha.
Do not reject at any alpha, correct?
Same for the last one.
It's, I think, no, it's significant. No, this is standard error because I looked at the 2.7. Because I looked at the, but it's T, in fact, T star. Is it significant?
No. Do not reject.
Do not reject at any alpha level.
Yeah.
Right? Which one?
So I was just looking at the apartment vacancies.
Still in some, not quite. not accept, especially when you talk about the predictions for some sort of the real estate and financial firms. Do you know why? Because we talk about non-monetary items, very easy to convert to cash. So you have to be more accurate. Association has to be at least 5. So to somehow, in some industry stuff, by the way, when you run the regression using Stata, this one will be significant at 10. It's still significant at 10. But, if it's
Wait, office vacancy.
Yeah, no, apartment.
It is significant at 10.
Yeah.
I thought it says it's not.
No, it's significant, but it's not
It's
very weak.
Right, okay, yeah.
So that's why we reject null hypothesis. I do not reject null hypothesis. Because maybe if we work more, this one will decrease to 1.50 maybe. Right? Because this is first output, Excel output. If we do more, maybe this will be hungry.
So
but for the first one, 12 point. If you work for the whole day, the association will be same because it's very strong. How much? You can make it 8, 7, 5, 4, 3. It's still
10 to the power negative 10. So
right. Still very significant association.
Yeah.
Very strong
So that's the
statistic.
answer for G. Which independent variable appears to be the best predictor of plasterboard demand.
For sure. What's your PEM exactly? Very significant variable. So if you conclude now, conclusion, you said only payments positively associated with. Positively associated, right? Yeah, positively associated to it. This is the nature of the question number 6 in your final exam. In addition to what we have done last week, like how to predict, I said to you guys, you have to put, before the model, put word predict or estimate. Because I want to check that you understand the prediction. Right? Remember, we didn't put.
It's a prediction. Or
Right? You put predict or estimate.
Yeah.
Please. Otherwise, you're going to have half of the mark.
Yeah.
Not 0, half. Flexi. Right? Right, guys? Okay? Got it? You have a question? I'm not going to listen. I'm not going to look to Nathan. I said, not me. Okay? You got it, guys? Any question?
Not at this stage.
No, this stage. Jump to the next exercise.
Is there another one?
To the next model, which is the last one for today. Model 11. So would you like to have 5 minutes rest? Please.
Sure.
Take.
Nicely.
So have a 5 minutes rest, guys. I'll come back to finish our new model is easy.
I noticed it's a bit smaller as well.
Very small. Compare with, because we did some changes. So last semester was a bit broad. Now we dropped some stuff.
Right.
Well, it's not a major stuff, like additional explanation, which is just funny, because we're interesting with this stuff, like, will help us to address the issues that we're dealing with.
Yeah.
That's it, no more.
Yeah.
What is his name? Franco?
Jaron.
Jared, huh? So, well done. Put some charger.
Oh, nearly done.
Yeah. Next week, just we have 12 questions
And tutorial question.
and revisions. Please put the mock exam.
Mock exam?
Today I'll release the material.
Mhm.
I already upload the check the material of the final exam and the consultation, because it will be different than the one regularly Friday, Thursday and Friday. So it will be on Monday and Thursday. And I'm not too sure, but I already changed it and released it. So in one table or for the pre and post in one Word file.
Is this the consultation? Sorry.
Pre and post exam. It will start from, because the new consultation,
When you say post exam, you mean after the actual exam?
some of them want to come and see his
Their
exam
exam
papers.
results. Yeah. Okay.
The Tuesday class, they said we don't want to see our exam. That was nice journey with you guys.
Yeah.
So you still have another couple of units for semester 2, right? Are you gonna? Nathan will be in.
Yeah. I'm doing a graduate diploma at this point. I might do masters. I don't know yet, but at this point, I'm going to graduate with a graduate diploma in professional accounting.
Okay.
And we'll see. I'm not sure whether I want to do the masters now or later or
Let me prepare the blackboard. So that one done. Number 11. Let me open the files of.
Sorry? We've been doing job applications and interviews and things like that. I haven't got anything yet, but worst case scenario, my dad runs a tax practice, so just getting the work experience there. Yeah, that's the plan at this point in time. See how I go. One to hear back from a job interview here at Curtin, actually.
Okay.
Yeah. It's either today or tomorrow. I'm going to get caught up about it. Yeah, I reckon.
Yeah. Are you happy with how it went? So.
Yeah, I am. I think the interview went really well, actually. It's just a matter of people looking after me.
Yeah.
Okay, that's one to 10 done.
11. Number 1.
Put this away now.
This is a model 11. It's health science, pure health science work.
Right.
Yeah, because in finance and accounting, we use regression techniques. That's why we start from descriptive. When you read any paper, they start with descriptive and then correlation, regression. Within the regression, there's F, there's ANOVA, there's Z-score, there's number of observation, degree of freedom, within all the regression process. But here, that one is used by health science. As my wife doing PhD, so she got around 200 participants in Perth and Adelaide, patients who live with dementia in community. So she's a she did a lot of tests, health science tests. So they use the pixel model, one of this. It's in health science.
When would you, so in accounting, I think I read a little bit of this. In accounting, when would you use this stuff? Is it like customer survey kind of thing? You wouldn't.
Customer survey, not accounting.
Yeah.
It's marketing.
Yeah.
But business, we use it for marketing.
Yeah.
But who cares about just to show that, to make an immediate that our customers, and I mean, the prediction of, I mean, because there's categories, interesting, strongly interesting,
Agreed.
independent, degree of, this is sort of a legal measurement, they call it.
Evaluate for
Yeah.
students.
Yeah.
Student evaluation.
Yeah, I know.
Five.
I hope. So maybe you'll be independent? Or no comments? Or maybe no
I
evaluation?
reserve the right to hold my silence.
So please don't forget to evaluate.
Yeah,
Have you done the evaluation? Not yet.
Not
Not
yet,
yet.
but I will.
I think we just got no for assignments.
Yeah. One more quick assignment.
Yeah.
I feel like the lecturers bullied us in those assignments, so that's
Too many assignments due in one week.
Maybe we'll go with less evaluation because of the stress. Let them, let's give them zero evaluation. Are we good, guys? Franco.
Oh, please continue.
Okay. So guys, today we're going to have a new model. We call it non-parametric statistics. It is comparing two accounting population. If you remember model 6, do you remember model 6? We use two samples, like mean mu1,
Minimum two.
and mean, do you remember it? Yeah, good, you still remember it. Guys, it's a one question of final exam. Please listen. So do you remember model 6? To be part of your final exam. In model 6, the sample was mean mu1 minus mean mu2 equal to 0, for example, or different than 0, less than or greater than. Do you remember this one? It was parametric, because sample is normally distributed. But today we're going to have different things. The key for this topic is the data ranked based on some sort of category, and the example is not normally distributed. In model 6, we assume that the sample is normally distributed if central limit theorem satisfied, for example. If it's sample, if it's proportion n times p. You remember it, guys? Greater than 5. But in here, we have none in the question, guys. In the sorry, I put it on my necklace. So in the final exam, guys, or within our model today, when we have any exercise, we will say it's not normally distributed, or the sample is not normally distributed. That means the data that we have is not normally distributed. If we get that one and check whether it's independent or independent, it depends, because we're going to use different techniques based on the nature of the data. So for example, we're going to have 3 different techniques to cover this model, non-parametric. The first one, we'll call it Wilcoxon ranked sum test. The second one, Wilcoxon ranked test, in fact, is a test that depends on the nature of the variables, like it has to be independent, and I'll go through it, guys, in details. And the data has to be not normally distributed. If you got these characteristics, that means you're going to use non-parametric Wilcoxon model. Sign test. In sign test, we have something we've done before. We call it masked pair experiment. Do you remember it?
Yeah.
That one depends on which one? Incremental, or differences between x1 and x2. xd equal to x1 minus x2. You remember it, guys? You got it? But in here, and we'll cook sometime the third one, it's mixed between these two, which is important. What is the difference? Model 6, we was interested to find the distribution. But here, we're going to determine the location. Not distribution. See the differences? How are we going to do that? Let's go and see how we go with it. At the beginning, guys, in order to determine the model that we're going to use, the non-parametric statistics technique, which is our model, presented by the data designed to compare two populations, it has to be ranked data, okay? And we are interested to find the location of the data. So location A, location B, for example, right?
That's different to the mean.
Yeah, different. Not mean stuff is distribution. Here's the location.
Okay.
Does the data have to be in order?
Let's see how we go. It's very easy. But easy when? When you review it and understand it.
Yeah.
It will be easy. So testing, here, this is your requirement. The locations. Location. So location. Maybe none, for example, we have two samples, A and B. Every sample have a couple of observations, right? But maybe location A will be on the right-hand side of location or the left-hand side of location B. Depends on the nature of the question. But, normally, within such cases, we will refer in the question, we will say that the data is not normally distributed. Why you don't put this note in your booklet? Please put it down. Put it? Okay, good on you.
And the population is not normal.
Good on you. Good. So that make it more easy because you're gonna get confused, guys. You're gonna confuse because there's another requirements we're gonna do. If I said it's not normally, population is not normally distributed, that means we're gonna use. But still, we need to see the nature of the data, whether it's independent or non-independent. Okay, or match pair. Let's see with the models. So if you remember, before, on model 6, we refer to this one, we have mean 1, mean mu1, and mean mu2, right? So can we say mean mu1, mean 2 here? It's different locations. That means it's not correct to say mean mu1 and mean mu2. It's location A1 and location 2, right? How to identify this one and use the right technique? But the most important part, the data is quantitative, right? And population not normal. Quantitative, population. That means I will provide you with the numbers. Okay? Don't worry about the originality of the data. Maybe it comes from the surveys. But after that, I clean it and provide it to you. So the number of observations will be too less because you have to do a lot of calculations. So maybe it will be 10, 11, 13, around that. Okay? Because the question will be not simple like the one where we're going to do. It's a little bit different, but I will give you some stuff. The nature and total in general of the data in here, it has to be ranked data. Why we say ranked data? When we want to address such a questions with Wilcoxon model, we have to rank the variables after sorted. For example, I'm gonna show you, but I'm talking about the originality of the data. The data, for example, we have a survey to take the opinion of the audience regarding or the pupil who live in Perth about one sort of products. So the options will be excellent, good, fair, block. Okay? So when the data is ranked, the statistical technique can be applied such as static rank process. This is ranked data. So when we say ranked data, that means if you have example, we have to rank data from 1 to the end. How many observations do you have? 10? The rank will be till 10. 1, 2, 3, 4, 5, 6. Because later we're going to add the rank for the positive values, and we assume that is the test, t-test. All right? So let's go with the example, because this is just theory. So the first model we have today, guys, which one? Wilcoxon rank sum test. See the characteristic of Wilcoxon sum test. Independent sample for independent. Highlight this one. For independent sample, okay? So the characteristics of this, so you have to be careful that, so this is first model or technique we're going to use. So when we're going to use Wilcoxon, guys, instead of sign test, Wilcoxon, the data has to be ranked. When we have data, we have ranked it from 1, 2, 3, depends, combine it, I will show you how to do it. Or it's quantitative, but has to be ranked, but not normal, highlighted. The sample are dependent, A and B, men and women, big 4, non-big 4. All of you guys done the no different. Just there is 2 different, by the way. Anyway, the sample are, this is very important point, because if we met these 2 conditions, but independent, the sample is independent, we're going to use different techniques. Okay? We're going to have an example to illustrate that one. So when we have an example, guys, in here, so what they said in here, example 20.1 in your book, you can find it. Based on 2 samples shown below, can we infer, see the question, that means we're going to have tests. Can we infer at 5% significant level that the location of population A is to the left of the location of the population B? What do you think, guys? Here, the sample is A, so we have 2 samples. So is that dependent or independent sample?
Independent?
Independent, because 2 different samples. So the nature of the hypothesis will be like that. Hypothesis, null hypothesis, the 2 population locations, see guys, we refer to the location, okay, are the same. Okay, let's go back to the question and to see what is the nature, or we want to determine now the alternative that we're going to test, right, Nathan? Nathan? Yeah. Or Franco, right? Based on the question. Can we infer at 5% significant interval that the location of population A, of this population A, the first one, is to the left? Why we said left? Because we are testing the location. We're testing to find the location of the location of population B. Okay. So what is? That's the tax of the teaching. You have to change your shirt every day. Okay? So, what we have to? Okay. What we have to do, guys, in here. Yeah, I got it. Thanks, Franco. What we have to do, the first step is to combine these 2 samples and give rank for each observation here. So, the first step, so what we have, guys? We have 20, let's combine it first. I want to go step by step from the scratch. First, combine it. 22, 23, 20, okay? 18, combine. Okay? 18, 27, 26. First step, to combine both samples. Okay? Then, the second step, sort. How to sort from smallest to highest? Tell me, guys. 18? 20, 22, 23,
26,
1, 2, 3, 4, 5, 6. 6 observations. Now, correct, right?
27. The last one's 27.
By the way, I'm fasting. 27.
Ah, yes.
Yeah, right? So now, what's the next step? Give rank for each observation here. One, 2, 3, 4, 5, 7, 6. Sorry. Okay? 1, 2, 3, 4, 5. Because 27, I said 7. Okay? So the first one, we have to give rank. That's why 22 in here took the value of 3. Right? Sorry. 22. 22 took the value of 3. Right? You know now in front of you guys in your stuff how to get this? Okay. What is the next step, guys? So we ranked. So we put the sample in total in here. Right? 2 plus 4 plus 2, we got 9, right?
Yeah.
1 plus 6 plus 5, we got 12. That is the summation of sample A and sample A. Rank. Okay? You got the point, guys, of this first step? Because rank and sort is very important. Sort first, sorted and rank. Then, because later we're gonna, when we combine these two models, Wilcoxon and cing, we're gonna do another different. We're gonna have another things between absolute and rank. Anyway. So, in here, commonly we choose the smallest one, smallest value, right? Smallest sample. Let's choose TA is equal to 9, okay? What happened in the example, in the question, in the question, they have 2 different locations, but it's not normally distributed. Right? In the question they said, not normally distributed, maybe squid on the left or we don't know, we have to do the histogram, okay? They said the red, for example, will be smaller than the blue one in the example. So, rank first and see the sum. We took so now T, the T stat in here is equal to the TA, which is the smallest value, equal to 9. So, okay. So what's the explanation here? This is some conditions, guys. See, if the two population, A and B, have same location, the null hypothesis will be true, highlighted. Okay? So, if the two are same, that means we met the null hypothesis, right? A small value of t, which equal to 9, right? Right, guys, equal to 9 in our example.
Yeah, 9 TA.
Indicate that the most of the smaller observation are in the sample A, the most of the longer observation in sample B. That's the whole case, what we have. If t value is small, see, this is condition. The null hypothesis should be rejected. Right? Because it's different from the, in favor, because t value in here equal to the smallest one, which equal to the 9, which is the smallest one. That means the null hypothesis has to be rejected, right? So let's test the critical region or critical values. What is the critical value? Sin significant at 5%. But how to do that, guys? See, this is important to understand. Similar with what we have done in model 5, right? My memory become like flipping up and down. So if alternative hypothesis, same with what we have done, but here we're interested with location, not with the distribution. Okay? If the null hypothesis, the location of population different from the location of B, that means we have two-tailed test. How? That means we have something, we call it T upper and T lower, right? Why T upper? Because two-tail test. T lower and T upper. All right? That is the rejection region. Sorry. Okay? Okay. What's the second condition? If alternative hypothesis, in case the location of population A is on the right, that means greater than, right? On the right-hand side of the location B, the reject null hypothesis. That's one tail test on the right. Means T upper.
Less than
T upper. Okay? That is the rejection region. Because we're interested with the upper and lower location, not distribution. What's the third case in here? If alternative hypothesis, in case of the location A is to the left, means less than, okay? So T lower will be on the left-hand side, right? T lower, not upper, right? And here, T lower. Right? Same, but not normal, not distribution. We're going to have location. Same. Okay? Got it, guys? So if you check, for example, we want to test so, at 5% significant level, can we infer that the location of sample A will be located on the left of the location B? So, do you have your appendixes? Open table number 8.
Have you got the textbook?
Yeah, I'll bring wine with me. I'll show you guys. So how many samples we have? N1 and N2, right? N1 equal to?
9?
3. And N2 equal to? No, sample size.
Oh, so both equal to 3.
3, right?
Sorry, N. T.
I'll show you what is in this one. Hello. I think manual is better. Right? It's not working, right?
No.
Huh?
Turn it on.
It's on already. Yeah. It's off now. Yeah.
What was that there, was it?
No.
Don't worry about it. I'll show it to you. Just a couple of students. So let me just highlight it in here.
For N3 and N3.
Confirm that with you.
Yeah. Okay.
Okay. So Where's my plus? Oh. So Nathan and Franco, see? So at 5% and 10%, we use T, N1 and N2, 3 by 3, 6, 10, 15, right?
Yeah, I see. Yeah.
Go ahead, Nathan. Yeah, good?
Yeah.
Oh.
Yeah.
No, go forward. Like that. So go. Yeah, check the 8. Yeah, N1 and N. So we have N1 at 5%. N1 equal to 3 and N2 equal to 3. So that means cross of the 3. So the T lower equal to 6 and T upper equal to? Pendulum. Christine means pendulum, right? See here? N1, 3 observations. And N2, 3 observations. That means T lower and T upper. 6 and 15, right, guys? Right?
Between 6 and 15, do that rejection.
So that's the original. Please note down that table 8, appendix B. Please, and down to the...
The T lower, we need 6.
At 5%? 3 by 3. N1 equal to 3, N2 equal to 3. If you go back to the question. So the N equal to 3 observations, N1, N2, 3. It was 6 in total. 3 by 3. Right? Yeah, that's it. T lower equal to 6, T upper equal to 15. Right, guys? You got it? Right?
Do we always choose the smallest of the two samples?
Yeah, it depends on the, because here the left means the smallest.
Yeah. So if it's we're doing a right-tailed test, right-tailed
Yeah,
test.
but normally they use the smallest and test.
Okay.
Because if it's critical.
Right.
Okay? See. So what they said in here, guys, they said T, if you said, let's say T less than, because what we have, the nature on the left, that means less, right? So they said T, which equal to 9, okay, the alternative hypothesis. They said T less than TL. That is the nature of the question, equal to 6. So, and the T equal to 9. That means do not reject. Why?
Because T is greater than or equal to TL.
Right. So because T, in this case, greater than or equal to T. Right, guys? So let's say the rejection is 6. The rejection is 6, has to be small. So let's say, okay, this is where we found the critical region, 6, right? How about the T value? This is the rejection region, because less than, the rejection will be on the left-hand side. So what's the value of T? Same with what we have done. But then here is the location instead of the distribution. So the T equal to, let's say Z. Z equal to 9. So reject or accept, so it will be greater than, right? Not here, it will be in here, 9, right? Okay, got it? So that is the nature of such a question. So maybe the next couple of examples will be more, because, so here we don't reject because T small or T A will be in the non-rejection area. All right? So the next, that's the requirements. Okay, let's see the requirements. So a rejection of the null hypothesis when we perform non-parametric test can occur due to the differences in location, which is the most important one. So this one, or different and spread, it's not known, but if there is differences in location, if there is differences, no matter less or more than, depends, greater than or small than, no matter, but there's some differences, that means you're going to reject null hypothesis. The location A will be not same to the location B, reject null hypothesis. Don't worry about the positive or negative in here. It's different than the distribution, okay? Since we are interested with the location, we are required to do two distributions are identical except the location. Okay?
Is that an assumption that we are making?
Yeah, that's it. But the hypothesis is the same, like the A and B is the same, or on the left-hand side or right-hand side, or different than there are some differences. When we got that one, this three condition we reject. Otherwise, means it's same. Location A and location B are same. So, but when we took the smallest value because it's less than, that means, but the T lower will be less than the critical. That means the T A, which is the smallest one, will be in the no rejection A. That means don't reject no hypothesis.
Yeah.
Okay. Scientists. So in scientist, do you remember? I keep remembering you. Model 6. What was model 6? Comparing two populations, but was normally distributed. It was independent, and then other case was matched pair experiment. This is sign. Why we said matched pair? Because same participant, but have different experiments. Like here we have an example. One riding, we have 26 out of 27. I don't know. I will see it. Both pupil, the one have 27 person, right? Both, each one have two tests. One time he used Japanese car, another time he used European car, and he gave his opinion. Whether good, not good, strongly good, something like that. That's why we got it quantitative. Because when we have 100 surveys, guys, as accountant, we use the final numbers. 27, 26, 23, 20, depends. Because we clean it and filtrate it. And make it ready to use in the regression. Make it ready the numerical values. And quantitative, we can use it to find the association and the weight between X and Y. Right? So in here, the problem is objective compared to population, same, but the data are ranked. The experimental design is matched pair. That means we are interested to find the incremental value or differences between X and Y. Do you remember? Mm-hmm. We call it. What's the statistical character of that?
B. Yeah.
Do you remember it? Anyway, we're going to do it in Excel, this thing, but you're going to do it manually during the exam, if it's on. Anyway, so we are interested into the differences between the value X and Y. Right? Here are some values and here are some values. But it's matched pair. Sample, or let's say design or descriptive, will be person number 1, person number 2, person 3 to 10, for example. And here we're interested, so XD will be maybe positive, negative, 0. 0 sometimes, but the 0 will be excluded from our calculations. That's why if we have sample size equal to 25, but there is two differences equal to 0, that means the sample size will be 23. Did you note down this one stuff, right? Huh? With me, guys? Okay, let's have a question. A straight example. Okay, this is important. Okay, see. Let's complete the description of the nature of the scientist, guys. The hypothesis tested will be null hypothesis equal to 50%, right? And the null equal to different than 50%. The P in here, guys, the P in here, it's a positive differences, means the P will be the positive proportion. Okay? Noted? Positive proportion, P in here. It will follow binomial. That means you're going to get test Z. Right? Z. X or NP. Do you remember these conditions?
Yeah.
What the number?
Greater than 5.
Remember the number?
5?
3.
3.
The base on 3, but we extended on 4 and 5.
Yeah.
Minus? Minus or different?
Don't know.
All right, guys? Model number 3. So, n times p, or n minus 1 times minus p, greater than 5. Remember it, guys? So in this case, we're going to use z. When? When we're going to use z? When the sample size is greater than 10. Okay? That means we met n and p. Okay? Greater than 5. Just put arrow in here, guys, if you like. Okay?
Oh, that substitutes that test, right? So we don't have to do NP and one.
No, you have to use this one.
No, but we don't have to do the test for the normal variable.
No. That's, because you're going to assume that it's normally distributed. When we assume, you forgot it? I don't want to mention the model number 3 stuff. When binomial approximate to normal if we met this condition.
Yeah.
N greater than 10 here.
Okay. Yeah.
Right? Model number 3. Okay, guys?
Yeah.
It's good to have something renewable. Renewable energy, right? Yeah. Okay, so let's illustrate that. So upon null hypothesis, number of positive differences, guys. Please highlight this one. And the number of negative difference, but here's P is the positive differences, okay? Because later when we take the differences, so what's the number of this? Okay. Let's see with the, let's say that by point to example. Please have a look during your own time to the one and try to do it by yourself. I'll show it to you how to do it, but please do it by yourself. So that will help you to extend your knowledge. So 20.4 example. So then experiment to determine which can has the more comfortable ride. Okay, 25 people took 2 rides, right? So that means everyone took 2 rides, right? One time he used European car model, another time he used Japanese, and he expressed his opinion whether it's comfortable or not. Each person ranked. 1 is very uncomfortable, and 5 is very comfortable, right? Is it independent or match pair?
Match pair.
You sure?
Yeah. Same people,
Check.
2 different tests. Yeah. Respondents.
Note, the data are ranked, right? The data are ranked, right?
1 to 5.
So when you got that data are ranked means non-parametric.
Non-parametric. Yeah.
Non-parametric, okay? So what's the hypothesis, guys? More comfortable, greater than or less than, or different than some value. The hypothesis alternative.
Greater than 0.5.
Why? Because more comfortable, right?
Greater than or equal to?
Huh?
No, greater than.
Yeah.
Yeah.
Greater than.
Yeah.
Man. Okay. See, guys.
Yeah.
Okay, before that. That is, let me show you the original 2.4, right? 20.4, the example number?
Yeah.
I don't have that. So this one is flexi time. No. I think it's available on that different. Anyway, it's available on Blackboard and your material. But I'll show you the next example. I'll show you how to calculate. Okay, that one is different. Anyway, don't worry. Okay, so I'll show you how they calculate. Okay, that is the original data, guys. This is the original data. The data will provide it like that, for example. And what you have to do, by the way, there is more than, because this one is, I think there's 25 observations, okay? This is just a snapshot of the data. So data all, not all shown in the stuff. So what you have to do first, okay? Okay, this is the next step. This is the original, this is the differences. Sort, and then take the difference. 3 minus 4 equal to minus 1, right? Blah, blah, blah. Till there is 2 zeros, I think. Right? Maybe there's another value. 2 zeros. Anyway, do you know how to take the differences? Let's say x1 minus x2. Let's say that equal to xd. Right? The differences same. You got it right?
Yeah.
Does the data allow us to conclude that 5%? Let's see how we go with the calculations. First, we have to note down the hypothesis from which determined by the question. So more comfortable, the right-hand side of the test, right? We're going to use Z. But see, guys in here. See, guys in here. So x equal to 17. Why 17? Because the values with positive sign equal to 17. And values with negative sign equal to 6. Values with 0 sign equal to 2. But you said x equal to 17, the positive. Okay? N equal to 23. Because of the formula, I said x minus 0.5 times n. This is very important formula. So the formula was, all right, guys? Z equal to x minus np divided by square root of n1 minus p, right? This is the formula, right, guys, the originally?
Yeah.
np, no, sorry, np in here.
Yeah.
To be more accurate, np, okay, 1 minus p. If it's n equal to 23, that means approximate to normal distributed, because n greater than 10, exactly. At least n equal to 10. So I mean we use Z. Okay, when we check Z, and we found that Z equal to 2.29. What is the Z alpha at 5%? Reject or accept?
Reject now.
Good on you. Ah. Do you remember the one I provided to you? By the way, the Z value at 1 and 5 and 10, you have to remember, guys. Because this will live with you. At 5%, 1.6. At 1, equal to this. At 10, equal to this. The one I provided to you, do you remember it? I printed for you.
Yeah, yeah.
I handed to you one by one.
Yeah.
I said this will leave you till the end of the semester. And today is the last model of the accounting 2008, 5, 8. because 5 at morning, 5,008 at afternoon. Right, guys? So what do you think? Reject or accept? Reject, right? Why? Because if we note it down, the Z alpha 1.645, and this is the rejection region.
European cars are considered more comfortable.
Yes, for sure. No need to do taste. European car more comfortable, or US more comfortable, and more safe than Japanese car. But if you buy a Land Cruiser, this test by the Yaris or Corolla, maybe. If you add to your Land Cruiser or this sort of Wolfie car or this Lexus, sometimes maybe it will be it will be negative significant, right? Maybe you're gonna accept null hypothesis, right? You got it?
Yeah.
Oh, guys, you got it, guys?
Makes this the poor man dinner, isn't it?
All good? Still a bit thinking, huh? Right, guys? You have a question? So you say like this, because I'm specialist in expression, by the way. I have one project in facial expression moods, like when you become anger, happy, sad, some stuff. Like there is 52 action codes developed by Powell or something like that too.
Facial expression.
Because now we are developing a new software to capture some stuff. Anyway, this is just for fun to keep your attention. All right, guys? This is just use the formula. Same with what we have done, but location in here. Okay? So if you buy a book from the publisher, I think they provide an Excel with it, right?
Yeah, there's like a code.
If you use Excel, there will be extra function not available with the one that we use from Keratin website. If you go to the data analysis, you're going to have an option, additional function. This one is called sign test. So that's why the Z here is equal to 2.71. But this is Excel output.
Okay.
No one knows that.
Yeah.
Guys, I don't want to hide something for you guys. I want to give everything extra, not. Alright, guys? This is 2.71. Don't be confused. This is Excel output. But still use our requirement.
We got 2.29, is that right?
It's almost same, not how much, because we said decimals are not fair. At least we got 2 Z. Still reject null hypothesis.
Yeah.
You got it? Okay. So what's the last thing we have?
Mix.
Wilcoxon sign ranks some tests for matched pairs. So the conditions in here will be quantitative but not normal. Okay? And the sample is matched pair. So still, in the final exam, I will say, you have to put your heart, not normally distributed sample.
So this is parametric.
Non-parametric. Non-parametric. Our model today,
All of it.
non-parametric. Everything is non-parametric today.
That's the same as just a third test.
No, this one is quantitative, not ranked. Is that right?
No, it's ranked, but it's quantitative. Why? Because we're going to use continuous numbers.
Oh, okay.
At the beginning, we provide them.
I see.
You got it?
On a scale from 1 to 10.
But we give them, so later we're going to combine all of these surveys.
Yeah.
At the end, we're going to have continuous number.
Yeah.
Numerical. So we're going to use That's why we say quantitative.
Yeah. Okay. Yeah.
Okay. The sample are matched pair. Okay. Building t-statistics, based on the rank sum of positive differences. So we're interested with positive differences between paired observations when the differences take them. So find test P critical for table 9 of appendix. Which one? B. So now, table 9, guys. Table 9. Let's see how we go with it. Okay, here we go. Example number 3. Still hard. 1 hour. 10 accounting. Okay, what's the condition? No condition. Because it can be addressed by, anyway, 10 accounting secretaries were selected randomly and the typing speed, the number of words per minutes, were recorded for each accounting secretary on 2 different brands of keyboards. That means everyone have 2 trials, one on each on different brand of computer. Right? It's match pair. Okay, let's see. Assume, see the question, the nature of the question. Assume that the typing speed are not, very important note, right? So you can say it's match pair and not normally distributed. What do you think? What are you going to use?
Wilcoxon signed rank sum test.
The long name of the stuff, or Wilcoxon signed rank sum test. Okay? So can you infer that, or perform with Wilcoxon signed sum test to determine whether this data provides enough differences or evidence, at 5% significant level to infer that the typing speed is different for 2. That means we have 2 tests, right?
Yeah.
Different.
Different.
Good. Okay. So what you have to do in here, guys, so that's the nature of the data we provide. What I will do, so I think it's available in my side. So match pair experiment, quantitative and non-normal. This is all on n equal to 10. All provided by the question. So when you find all of this information provided, guys, what are you going to see? You're going to use the next one. Okay? Or Cookson sign test. Some sign test stuff. Okay. So okay. So what I'm going to do, I will copy, I want to copy the original from the table because I don't have the data in my database. So I'll copy it from the original. I want you to follow me step by step. And note how to find the difference, how to rank, how to sort, how to create ABS, absolute value. Here we go. Okay, so now I'll paste formula. Okay, make it too big for you guys. Okay. So the first step, guys, we have to find the difference between X and Y. Let's say difference. Okay? How to find the difference? Equal to this one minus directly this one. Enter. Double click. It's good to have Excel during the final exam, huh? Like this. Okay? The second step, guys, we're going to have, we got the differences. We're going to take the absolute for differences. Okay? Absolute for differences. Abs for diff. I want you to do that one in final exam. Guys with mobile, please look at the screen. Please, this is very important for you. I will mark your exam papers like sharp. If you miss one column, you miss you did something wrong. So take the absolute. You can, because the number of observation in final exam will be too late. I mean, 879, so it's too easy to calculate. But you need to know, you need to practice. That's why I said to you, it's available on the blackboard and in your book, the examples. Do one practice. To know how to get the differences, to know how to get the absolute by the small scientific calculator, how to find the absolute value for each of the differences. Why? Because we want to take the positive values, okay? ABS equal to ABS, okay? Of this one, okay? So that's the absolute value. But what we have to do, we have to mark this negative values because it will be excluded from the calculation, because we are interested with to calculate T plus, T positive. Okay? Now, let me grab the stuff in here, the rest. Okay. First step, guys, tell me which steps we've done. Take the differences, take the absolute. Can someone tell me why we took the absolute value? If we are interested with the just positive, we can just depends on the positive from the differences column. That's a good question, right? Technically, can someone answer? 10 marks in the final exam. Just joking, son. Guys, we put the absolute value because we have to sort the value from smallest to highest based on the absolute differences. If we leave them negative, when we sort it, will be some missing stuff or some wrong sort. Why we sort in here? To give rank for the sequence. Because sequence in here, we have to find the sequence, guys, in here. So see, I will sort it based on the absolute and give rank. Okay, I'll sort. So how to do that? First filter for all, keep it filtered, and sort from smallest to largest. So we got very consistent sort, right? Then we're going to give sequence in here. 1, right? Correct? You agree with me? Okay. So how to rank the absolute value in here? The rank in here depends on the sequence values. See. Please look to the steps that I'm gonna do for it. See. And here, guys, we have two sequence value for, because you have two, for 1, 1, it's frequent, 1. We have 1 and 2. How to put the rank in here? We have to take the average value between n, because it's 1. It has to be 1.5, 1.5. How? 1.2 plus 2 equal to 3. Divided by 2, the average. Okay? C for 3, for 2. 3 plus 4, all right? 7 divided by 2 equal to 2.
3.5.
It's even number, not odds. If it's odds, we took the median, like. And here, 3, we took which one? Directly, 5. That is the rank. 4, because it's 1, 2, it's odd numbers, right? So we'll take the median. Which one is the median? The middle value, because it's 1, 2, 3. We can't say 6, 7, plus 7 plus 8 divided by 3. It's not correct. The rule or the policy or the requirement is to take the middle. If it's 4, what are we going to do if it's 4? The average of the middle values.
The middle two. Yeah.
I will show you. I bring one example for you. The average of the middle 2.
Yeah.
If it's 4. If it's 5, we took the third. If it's 6, the average of middle 2. Yeah. If it's 1, take the one, same directly. Got it?
Yeah.
You have to practice. So here with 6, right, 7. Is it correct, guys? Please follow up with me. Huh? So how about 6?
1.5, yeah.
Is it correct?
Yeah.
The total will be?
30. Because you take only the...
No. Wait.
Yeah.
Because sometimes I go fast. I don't want to go fast. So next step, we said positive differences. So how are we going to identify the positive differences? 1.5. 1.5, because both positives. Are we going to go negative? No, leave it. 3.5. Leave it, right? Leave it. 7. Sorry, 77. Will be more than 30. 7, okay? Leave it. 9.5.
Yeah, okay.
Total will be 30. Positive will be. Did you get the points, guys?
Yeah.
This is the steps. Very important in final exam. To know how to start. So the first step is?
Differences.
Second step?
Absolute difference.
Absolute for the differences. Then?
Ranked absolute.
No, sort from
Sequence.
smallest.
Sequence.
No sequence. When you got the absolute, sort from smallest to highest.
Yeah.
Then you give the sequence.
Yeah.
Because he was busy with the phone.
Oh,
But also with the phone. So first step is to take the differences. Before you sort, take the differences. Second step, absolute value for differences. Then we sort the absolute value to give a sequence for each value in our samples data in here. Okay? Then when you got, we have to identify the rank. For each value, it's negative or positive. But later, we're going to just conclude combine the positive values. So that's why this one excluded the red. I put it in the red. So normally in the exam, guys, when you do the calculation, take the differences. If there is some negative, highlight it. Take the highlight pen with you. Okay?
Yeah.
Highlighted, so it will easy for you to take the positive. Mhm. Correct? Do you agree with me?
Yeah.
At the end of the day? Please try to practice it. Just do one careful practice. Ooh. Like this in the final exam.
Oops, that's a 4.6.
Sorry, guys. Okay? I'm tired. Throat problem. So we have Ellen, Judy, Annie, Faith. I don't know this name. Ingrid, Carol, Dana, Heather, Billy, Joan.
Gwen.
Gwen or Joan? Because we call it Joan in our culture. There's Joan. There's Joanna.
Joanna is different. That's Gwen. We say Gwen here.
Gwen, oh, okay.
Plus you're in WA, so everything's literal.
Little?
Literal.
Ah, okay, literal. Yeah. Literally, yeah. Gwen, huh?
Gwen.
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 Gwen. It's a cultural society.
Yeah.
Multicultural society.
What a joke, what a joke.
Yeah, sure.
Multicultural society.
Gwen.
When it comes to English, we have to do it
Gwen.
our way.
Not my relative. It's Gwen. Gwen. But they also write it in, I don't know.
So
It depends on
N10, N10
and
in the table.
table 9.
Table 9.
So you got it right?
Yeah.
At 5%, table 9, you're gonna got 2 tail, 8 and 74, right?
Yeah.
So, and T plus 30. So don't reject because it's between
Yeah.
the extremes. Any question?
Last slide. So in the table we do N10, N10, upper and lower.
Yeah.
Okay,
For sure.
and that gives you 8 and 47.
So you should be
And it's 5%. Is
sliced.
it 5% alpha?
5% alpha.
Yeah.
Okay.
Two-tailed test.
It's 8 and 47, right? You got it?
Yeah.
You got it, guys? I have throat problem now. No more talking. Just sign. 10 observation and T lower, T upper for 5%. Okay.
Okay.
Two-tail test.
So it's in between the two rejection regions.
Yes.
Wunderbar.
No, this is different. Two-tail. Okay. So you got this point? You got the point, Franco and Nathan?
25 observations. We had 2 zeros. We had actually 23 observations.
So it's easy, right? So the 30 between, so we're gonna.
Oh, yeah.
So it's like we do it then.
So you got 10%, 10 observations.
So-
Don't know if it's the same or not.
Lower or upper, so rejection because it's 30 between.
We
Not
take
in a
away-
rejection.
So in the sign test, we took the zeros out of the end. But
Yes.
here we don't take the zeros out of the end.
If there was a 0 on this
If
one.
there were zeros, would we take them?
No, zeros. No.
That's a new sign test thing.
If you put 0, doesn't make sense because it will not going to add or reduce the t. It's 0. If you put it in here, 0. Okay. Good.
Yeah. I see.
Oh my gosh. 11 models and you're still letting go.
Even if there were zeros in there,
So not increase or decrease the t positive.
but our n values still are 10, 10.
Sure.
Yeah. Whereas with the sign
No, here is just 10 because it's matched pair here.
Yeah.
Here is 2. Well, Cookson, matched pair.
Yeah.
We use the table, but for matched pair.
Yeah. But the match pair is the sign test as well, right?
Sign test, yeah. That's why we mixed.
With that one there, 25.
Yeah.
N equals 25.
By the way, you can still use.
25.
No, you can still use Z in here
Right. Okay.
because it's 10 sample size.
Yeah, okay.
But don't use Z.
Use T.
If you use Z, you have to find additional calculations
Right.
to get N and P. So it's a bit complex for you.
Right.
Leave it. Just use with
Z and
Lucas.
T. Z for.
No, use table. Use the table.
You use the table.
Use the table.
With this
I
one.
think I read one additional book. I found that some of them they use it. They use Z. But they have to find the I'll call you because I noted down in here. Because you have to find the expected T first and compare it with T.
Right, okay.
So it's too complex formula.
Yeah.
Because even in final exam, when I put the optimal solution, I didn't make it too complex. So go through with this stuff. Very easy lecture, huh? Flexi. What's the slang? Okay.
With the sign test, just the sign test, you take away any of the 0 differences from your n.
And use the formula.
Right.
Okay?
Yeah.
Because n is the values equal to the values without 0.
Right. So negative, positive, but not 0.
That's n. But x is the positive.
Yeah. Okay.
Got it, Nathan?
Yeah.
This your
This is last minute. So guys, not finished. Next week, I want you to do one thing. Print the mock exam and bring it with you.
Yeah.
Take your time. Any question? We'll see you next week.
All right. Thank you, Bilal.
No worries. Oh. You don't have any question, guys? You sure?
Okay.
All the best.
Thank you.
And
See you tomorrow
So we're
morning.
going to have to do that in an exam? See you next week.
no. Confidential.
They
Huh?
give you a notes to everyone.
For sure, you have to have one question from this model. Maybe equal to 16. 16% of the total grade in final exam. So equal to 16 marks. Okay? 16 marks. All right. See you next week, huh, guys? Yep. Finish.
Another day.
Okay.
Done and dusted.
See you boys next week.
See you next
See you
week.
guys.
Okay.
So how about the ad hoc? Stop.